Now, there are times it's easier to use geometry to be able to figure out an integral than it is to go through that whole limiting process. When we look at this first one here, it's just 4, which is a constant function, which means we have a horizontal line going out at a height of 4 all the time. And we're looking at the area underneath that from 1 to 3, which you can see down below is then just the shape of a rectangle. And you guys know how to find the area of a rectangle. In this case, it's 2 wide and 4 high, so we get an area of 8. The next one here, you know, is just a line with a slope of 1 with a y-intercept of 2. So when we look at that shape, it ends up being the shape of a trapezoid. And to find the shape of a trapezoid, you know, we can go 1/2 your base. The base is the distance between the two parallel sides, times, and then we got to add the first base of 2 to the second base of 5 and work it out and get 10.5. Now looking at this next one, you may not recognize this one here in its present form, but if we go y is equal to the square root of a 4 minus x squared, now if you would go ahead and square both sides, because you're not used to seeing this form with the square root in it, and you're used to seeing it in the form where the x and the y are on the same side. Hopefully at this point you recognize that this is a circle centered at the origin with a radius of 2. So it's not really a full circle because it's only the positive root, which means it's only the top half of your circle, and you know how to find the equation of a circle. The equation of a full circle is pi r squared, but we only have the top half, which is a semicircle, so we got to go half times our radius of 2 squared times pi, so we get 2 pi.